So in this lesson of our linear algebra studies, we're going to talk about null space. Okay, so given that your matrix A or some given matrix A is an m by n matrix, the solution space of the homogeneous system of equations Ax equals 0. This is very important, where x is in the Rn, where n is the column number, right? It's called the null space of A. An example is if you have a system and you're solving like this. So here A will be this, and then this one will be x. So I have Ax, so A is that, and then this is x equals 0. And then here the 0 we are talking about is not the number 0, it's the vector 0, right? This is 0. Then if you want to find all kinds of vectors such that A times that x will give you the 0 vector, okay? So in the 2 by 2 matrix case, you can just simply do this matrix multiplication, and this is what you have. When you multiply these two, you have this, and this is equal to 0. Now if you have two matrices or two vectors that are the same, then it means the components are the same. So you have either this is equal to 0 or x1 plus x2 is equal to 0. In any way, you have two equations of the same thing, right? So you just pick one of them. So the only equation we have is that x1 plus x2 should be 0 from this. And that way I can write x1 in terms of x2 to be this negative x2. Now doing that, it means my x that I'm after, that is given by x1 x2, can be written as negative x2 because x1 is negative x2 and x2 itself. If I factor x2 out, I'm going to get something like this: x2 multiply negative 1 negative 1 1. Okay, so this becomes any, so because x2 here is just any value, it means that if you have any vector that is a scalar multiple of this and you place it here, this matrix that I have multiplied to that vector will give me 0. And that how you write that space is that the null space of this particular A is given by the span, and then we've talked about span in our previous concepts. You can actually look through or go through those videos and get to understand it better. Okay, so the span of that vector that I had here will give me the null space of this one, this vector, this matrix A. I mean this one, 1 1 1. All right, so the matrix is 1 1 1 1, right? It's a 2 by 2 matrix. So now let's pick a more complicated problem and then go through that. All right, so the first one, it was a 2 by 2 matrix, and mostly for 2 by 2 matrices we can do it in a very faster way. Okay, so find the null space of A equal to this. So the first thing you do is you want to find some vector x such that Ax equals 0, and that, like I said, the 0 here is a 0 vector. Okay, so here my x is defined to be x1, x2, x3, x4, x5. The question is, why am I having 5 entries? Because sorry about that, because my matrix A is a 4 by 5 matrix. Okay, and we said x belongs to R of the column or the column number. Okay, so x belongs to this R5. That is why I have x to be this. Okay, so all these things you should take notice of them. So I want to find a vector x such that Ax equals 0, and then the x is given by this. Okay, if you want, we can actually write a system of equation that says, so Ax equals 0, where this x, like I said, this x here is a vector. So what we mean in math is you write your A 2 2 negative 1 0 1, and then negative 1 negative 1 2 negative 3 1 1 1 negative 2 0 negative 1 0 0 1 1 1 times some x, which is giving us x1 x2 x3 x4 x5 to be equal to the 0 vector. Okay, so this is what we've gotten. So in a nutshell, in math, this is what we mean, that Ax equals 0 will give you this. And this, we've talked about how to solve systems of equation using matrices like this. So what we're going to do is reduce this matrix together with the vector you have on the right. Luckily for us, the vector we have on the right is 0. So whatever we do to the reduction, it will not affect that one. Okay, What I mean by that is you do row reduction, row 1 plus 2 row 2, and then row 1 minus 2 row 3. Why are we doing this? If you remember, you start on the first pivot, make sure it's a non-zero value, and then reduce everything under it to be 0. Already we have a 0 here, so we don't care about that, and we care about these two, right? And then to make those parts 0, you just have to multiply 2 to this one and then add it to this 2. That will give you 0. And doing same for the other one is negative 2 times this one, and then you add it to the 2, you get 0. Okay, and that can be written as row 1 minus 2 row 3. And so when you do that, we'll have a new matrix or a new reduced matrix in this form: 2 2 negative 1 0 1, and then 0 0. If you do the reduction very well, this is what you're gonna have. This reduction process, I've also taken care of it. We've also gone through that, so you can check some videos out and then try to learn how to do these if you think you don't understand. Okay, and then like I said, whatever we do for the main matrix, we have to do the same thing on the other side. Okay, the other side I mean is the vector you have here. So this is 0, this is 0, this is 0, that is 0, and then 0 again. The reason I'm saying that I'm putting it here is if this was not 0, if this part was not zeros, then we'll have to apply the same thing we applied here to those aspects as well. Okay, I mean I've taken or I've done lessons of what I'm talking about in other videos, so you can check them in my playlist for the linear algebra. Okay, so this is what I have for the first step. The next step is go ahead and make sure that the next non-zero value is this one. Make sure the values beneath that is zeros, right? So we do the same thing, and with that, the reduction value I'm going to use is row 2 minus row 3, and then row 2 minus 3 row 4. The reason I'm doing is row 2, this is row 2 minus row 3, so 3 minus 3 will give me 0, and then row 2 minus 3 row 4, so 3 minus 3 times 1 will give me 0. So I know when I do these operations, I'm going to have 0, right? So I go, and then when I do, my matrix or my problem tends to this. I have 2 2 negative 1 0 1 0 0 3 negative 6 3. I have 0 0 0 negative 6 0 0 0 0 negative 9 0, and like I said, you put your other vector here. Okay, on the other side, what we can do is just probably erase this. Okay, we're supposed to get a 4 by 4. Yeah, so this part is supposed to be a 4 by 1 because the matrix is a 4 by 5, and then the vector we are after is a 5 by 1. When you multiply these two, you're going to have a 4 by 1 matrix. Okay, so this is 4 of them. This is also 4, so like that. Okay, so I have 1 2 3 4 like that. So having this, the next thing I do is to find another multiplier such that the value beneath negative 6 will also be 0. So that's how you do it. Like I said, these process that I'm going through, I've taken my time on doing a full lesson on that, so you can check it out. So row 3 minus, if you want to really understand how you can do this, just divide these two. Okay, so what you're going to do is negative 6 divided by negative 9 times row 4, and I can tell you that this will tend to this will change the negative 9 here to 0 for you. Okay, or in the other words, what you are doing is you can divide these two, and you're going to have 2 over 3 row 4. Okay, so when you do this, it tends to 2 2 negative 1 0, 1, 0, 0, 3, negative 6, 3, 0, 0, 0, negative 6, 0. I have 0, 0, 0, 0, 0, right? So everything you do will turn to 0 here. 1, 2, 3, 4. And so when you are done with making sure that the leading values are all having zeros under them, right? The next thing you do is that you place your x1 here, x2 here, x3, x4, and then x5. What it means is that these are all coefficients of x1, these are all coefficients of x2, these are all coefficients of x3, like that, okay, all the way to x5. So having this reduced matrix, let me write it here. We have the matrix to be 2, 2, negative 1, 0, 1, and 0, 0, 3, negative 6, 3, 0, 0, 0, negative 6 again, 0, and then the rest of these are zeros. Okay. What it means is that what this whole thing means is that we have like I said, x1 here for all the first column, s2 second column, s3, x4, and then x5. Okay, and these are the values that correspond. What it means is if I pick the last row, it means the coefficient of x1 here is 0, coefficient of s2 is 0, x3 is 0, like that. Okay, if I go to, it means this whole thing will sum to 0, so it means that I have 0 x1 plus 0 x2, x3, x4 is equal to 0, right? It will be equal to this one, and it makes sense, right? This, all these things that I'm doing here make sense. So what I'm trying to say is that when you understand it like that, then we can say that the last part has zeros throughout, so we don't really need it when it comes to the null space, because everything will give you zeros, so you don't care about that. Now you go to the third row, okay, which has 0 coefficient for the x1, 0 for x2, 0 for x3, but for x4 we have negative 6 x4, and the x0 x5 is also 0, should be equal to this 0 here, right? So 0 means that x4 is equal to 0. And what the process I'm using here is called back substitution, right? You are trying to find a solution from the back one. So what I mean by the back one is you start from x5 here. We don't have 0 x5 equals 0 will not give us anything about x5, so we don't talk about that. We go to the part that has a value, a non-zero value, and then that is where we use what we use to find x4. Now on the other hand, if I go to the other side, this row, I'm going to have 3x3 minus 6x4 plus 3x5 is equal to 0, right? I know x4 to be 0, so I'm going to have 3x3 plus 3x5 is equal to 0. If I divide through by 3, I'm going to have x3 plus x5 is equal to 0, meaning that x3 is equal to negative x5. Right, so we have x3 in terms of x5. Now on the other hand, we can also go to the first row. Okay, so we've used all the rows. Now that this one that we did, we used this row. So the next one we do is we are going to use the first row. The first row has 2x1 plus 2x2 minus x3 plus 0x4, so just 0 plus x5 is equal to 0. Now this means that what is x3? x3 is negative x5, so I can put it here, right? I'm going to have 2x1 plus 2x2 minus x3, which is negative x5 plus x5 is equal to 0. Now this is 2x1 plus 2x2 plus 2x5. If you do the summation very well, is equal to 0. If I divide through by 2, I'm going to have x1 plus x2 plus x5 is equal to 0. Now I can only write x1 in terms of these two, so negative x2 minus x5. So this is what I have for my x1. Now on the to write a final solution, it means that my x is given in terms of x1 as this, x2, I don't have anything for x2, so I can just choose x2 to just be x2. Then I write anything for x5 because I don't have any equation for x5. But I know x3 to be in terms of x5, x1 to be in terms of this. So what I mean is that my solution that I'm after is x, which is x1, x2, x3, x4, and then x5. But in here, x1 is being found in terms of x2 and x5. That is negative x2, negative x5. x2, we don't know any other equation, so it's just there, x2 like that. x3 is negative x5, right? x4 was found to be 0, and then x5 is still x5 because we do not have any solution for it. Now, if I continue with that, it means I have some x2 in here, x5 in here. Let me try to split this into only values in terms of x2 and then values in terms of x5. So in the first part, we have negative x2 here, have x2 here, and then we have no x2 in terms of the x3 part or the third row, no x2, no x2 here. And then plus, and I have negative x5, 0 here, negative x5, because there's no x5 in the s2 component or in the second row, right? Negative x5, and then the other one is 0 and then x5. So what this means is that I can pull out x2 in the first column. I'm going to have negative 1, 1, 0, 0, 0. And I can pull x5. I'm going to have negative 1, 0, negative 1, 0, 1. Okay, so it means x2 and x5 can be any number at all, but the vector x takes this form. Some number times, some number is the x2 that I'm talking about. It's a constant, it's any value, times this vector, and then some number times this vector. Okay, so the vector I'm going to choose should be the linear combination of these two vectors, this and this. And this comes back to what we've learned before, the span. So it means the null space, I'm going to use capital N for this matrix A that we're looking at, is equal to the span of the set of these vectors. That's a linear combination of any linear combination of these vectors will give us an x such that AX will be equal to 0. Right? And the linear combinations are what we call the span, right? If you forgot any, like I said, you can go back and read or maybe watch my video about it. Okay, so that is the null space of the A that we're doing. So the null space, what you do is try to reduce the system to, or reduce the matrix to its row reduce echelon form. And when you are done with that, you try to solve for the zeros, right? You try to solve for these, you pick these times their corresponding x component, and then you sum them equal to 0. Try to write some of them in terms of the other variables so that you'll be able to split them into this. When you are done, you can pull out the values that are, or the constants that are standing out. When you pull them out, it gives you the vectors that will be in the span. Okay, so thank you, and if you have not subscribed to my channel, kindly subscribe. If you have subscribed, thank you so much for subscribing, and see you in our next lesson.